Hello and welcome back to another Unreal Engine tutorial. In this one, we're going to be working on the echolocalization effects, like you see in games like Lurking or Stifled, I think that's what it's called. So I'm going to be working on Unreal Engine 5.1, and we're going to be creating a blank project based on the first-person template. So go ahead and leave the settings as is. We're not going to be needing starter content. We'll call the project Echo. Also make sure you set the quality preset to scalable, unlike me, or the actual post-processor won't work. And we can create it. So we'll just wait for that to load. Now, once our project's loaded, we're going to need to first start by wait for the shaders. But the first thing we want to do before I forget is we need to go into our project settings. As for this to work, we need to enable something here. So we're going to search for stencil, and custom stencil pass is enabled, but we need it to be enabled with stencil, which pretty much what this will allow us to do is if we want to outline a specific object in a specific color, we can use this. So let's remove that. Compile, save. So now that that's done, we don't need to restart the engine for that, by the way. It's okay. So for this one, we're actually going to be working mainly in this scene. We're not going to change much because it'll make it easier to deal with. So what we're going to start by doing is we're going to be making our different assets. We don't actually need that many, but we're going to do that anyway. So we're going to create a folder we'll call Echo, and inside of it, we're going to create a few materials first. So the first one will be m_dark, and this is going to be the base material we have everywhere around the scene, because we need to have something completely dark without light to have the result that we want. So that's how we're going to be doing it, but to be fair, if you want to have this effect without the light, with light, that is possible as well, even though it's not very interesting. Next, we want a material decal, which is going to be the material for the ring we see. So we'll just call it ring decal. And two more materials. One we're going to be calling m_post for post process, and we're going to be calling it move. This is going to be the one that we're going to be adding. So actually maybe add will be more clear. We'll call it add. And the second one we're going to be calling m_post_permanent. So this one is going to be the default one that we're going to set on our post process volume. That will never be removed. It will always be active. And we're going to need one last thing, which is an actor, which is going to be called a_sound generator. So I'm just going to be giving you the basis of what I did, and then pretty much you can do whatever you want. So the sound generator is, as the name suggests, it's going to create a sound of the location you spawned it. So what we'll be doing is we're going to set it up in the, we'll set it up in the first person part, and we're going to be just simply going to be applying it here once the projectile bounces, because that's going to be very simple. We don't have to make too much code for it to work. Pretty much, if I remember correctly, inside of here, we're simply going to add impulse at location. We're going to remove, we'll leave the destroy and we'll call our actor here. So the first thing we want to do is we'll set up our materials because they're the key components here. Well, actually, we can also start by adding our post-process volume. So we're going to add that anywhere in the scene. And we want to make sure that we check unbound, because otherwise it's just going to be once we're inside, which is not very useful unless that's something that you're looking for. So this will leave for now. We're going to need it later. So back in our content and in the folder Echo, we're going to start with our dark material. So one of the things while I was working is here we actually have to do this a bit different. You would expect something to be dark to be simply a tick here, unlit, finished. But we can't do that, because if we do that, we actually lose the ring on the decal. It won't actually be visible, because I think how the decal works is it's additive on the surfaces. So it won't work because this can't have any additions to it. So we need to leave it as default lit. But to get the same result, we simply need to plug this into base color and plug it into specular. And as you can see, we get the same complete dark unlit color that we want. So apply this, save, and we won't be needing that anymore. Now, to make it easier on ourselves, we're actually going to leave everything like this, and what we'll do is either in the level blueprint here, or we can also do it in the game mode. We're going to call get all static mesh actors like this, and tell them to set the material to our dark material. So let's go to our next material. The next one is going to be our decal. Now, so for the decal, it's going to be pretty simple. We'll start off first by changing it to a decal, otherwise it won't work. So once we've done that, we want to make sure it's not opaque but translucent, because we need a ring. I'm just going to check there's no other settings we need to change. And no, that's all we need. So let's get to it. So first we want a 4 vector, which is going to be color, which we need to convert to a parameter, which itself will be called color, which will be going to base color, obviously, but also to emissive, so it stands out a bit. And next we're going to make our actual ring. So for the ring, I just want to check something here. Okay, so next up is now the location. So for the location, we're going to need to get a vector 4 or a constant and convert it to a parameter, like with the color, and we'll call it location. We're going to feed the location into a sphere mask, because that's what's going to act as our actual ring. So make sure you connect it to B, not A. And for A, what we want to get is get world position. And it's called absolute world position, but for some reason you can't search for it like that. Leave it as default. And now we need to set up our actual radius. So we're going to need parameters here as well, because it will get bigger. Well, it will expand. It won't be automatically big or automatically small. So we can press S for the scalar parameter, call it radius, and another one which we'll call hardness. Now, hardness we don't actually touch, but maybe you might want to. So we're just going to, by default, I have it at 0.97. If you feel like it's better at something else, that's fine as well. So we want to put this at 150 by default. Doesn't really matter. We then want to do a sine node, which is pretty much initially this. If we go and preview the node, it's just going to be a sphere. But if we preview the sine, it's going to turn into a ring, as you can see. So it's a bit off it because that's the size that we gave it, but that's going to change later, don't worry. And then we can clamp it just to be sure for safety, clamp it between 0 and 1. And to finish, we will multiply this into opacity, which will then make it so that if we stop previewing now, it's an actual ring. So we can also add, well, sorry, no, we actually want to put this, which is the value called intensity. And for the intensity, by default, it's 1. And what this will do is, for instance, when we want to fade it out, it will actually slowly disappear instead of just snapping out of existence. We also want it to be by default white. Looks a bit better. Let's put this at actually 100 so that we can maybe see the actual ring. And if we put this to 0.1, it's less visible. 0, it's gone. So let's apply that, and that's all we have to do for the actual ring material. So this may look actually a bit small, but in reality, once we apply it to the decal actor, it'll look perfectly normal. So next up is our final 2 materials, which are by far the most complicated ones because they're going to be dealing with the actual outline. We'll start with the permanent. We're going to be copying some stuff over from one to the other. So let's start with it. So the first thing we want to do is we want to make sure that it's set to post-process, because otherwise this won't work. So post-process, and we're only going to be using the emissive color, but we actually need to change one variable in here. We need to go into, at the bottom here, look for post-process material tone mapping. We want to change the blendable priority to 1, output alpha, and we want to remove is blendable. So the reason we do this is because we want to have an alpha here. Now for the permanent one, we're not going to touch it, leave it as it is, it's not a problem. But for the emissive color, we're going to put the outline here, but for the add post process that we're going to be doing later, we actually will be touching the opacity here because we need to tell it which areas not to actually affect. So now we're going to be working on pretty much the outline effect, and that's pretty much it in this part. So let's do that. So we're going to need a lot of space here, to be fair. So we're going to start with a 1 value here, which will be setting to 1. We're going to then pass this into a blur sample. Now this blur sample pretty much gets in, if I remember correctly, in local space, the different offsets you can have. So 0, 1, 1, 0, etc. So this is going to be pretty much getting top down and side views in the viewport. We're not talking about in 3D, but in 2D here. So what we want to call from each of these is a sample scene depth, and make sure everything's connected to the pixel offset here. So we're going to need 4 of these, so you can copy paste them, and they're going to go into, well, in order, pretty much. There we go. Now we're going to need one last one, which is going to be here separate, and it's going to have a 2 vector node. So call it here, and once again to the pixel offset, we're going to multiply this, and we want to connect that to the depth using pixel offset. We're going to multiply it by -4, and we're going to add. Now we're going to be adding everything here together, once again from the depth at the bottom, on both of these as well, and one last time here, and then we can attach this to the end here. Now if you're looking for more information on how all this works, I can leave a link to the tutorial I actually followed, which is a really good one. So if you want to check that out and maybe understand more of what I'm doing, then please do. Next we want to add an absolute, and for the absolute we're going to multiply. And if I remember correctly, the multiply we're going to get here is the thickness, if I'm correct, for the actual outline. So I'm gonna leave it at 0.1 because I'm not going to change it. We have no point in actually changing it. So we're going to do that. Then we want to call a power node, which will then do by 2. So we're not going to change it, so we can leave it like that. We can actually do the same here, 0.1. Next up, we're going to saturate this node, and we're going to multiply it, and we're going to multiply it by, we're going to get our scene depth node. So for the scene depth, I'm not exactly sure what it's for, but we're going to divide it by a very large number. So if we don't divide this, if I'm correct, we kind of get very strange, how to put it. At the edge of the map, you'll see a grid if you don't divide this by a really large number. So I think it's 8162 is what we want, and we want to 1 minus this. With the 1 minus, then we want to saturate it as well and put that into the multiply. Now right here we're actually going to add something later, and that's going to be to have custom outline colors, but for now we're just going to leave it here and we'll add that later. So then we want to perform a linear interpolate and attach this to the alpha, because this is going to be our outline pretty much. So we then want to get a scene texture node, and we want to convert this to post-process input 0. Then attach the color to A, and next we're going to need here is going to be the color. So if you don't want any particular outlines like a red for an enemy or a yellow for an interactable item, then you can just leave this as white. So that works fine, and then you won't have to add anything here either. But we're going to make it so that we can do that, so we're going to add the other parts. So for the other parts, it's pretty simple. We're going to call a named reroute node, and we're going to call this, we'll call it outline color. So for the outline color, we're going to work, well, from the start, let's say, we're going to get in our case, we're going to have simply full to start. This is going to be our default color. So actually, there we go. We'll just call this default color, just so that we're very aware of what it is. We're going to add a lerp, and the lerp is pretty much going to be A. On B, sorry, we're going to use this. And then we're going to have a, well, we'll leave it at 1. We won't do any more than that. We'll then go and put this into a multiply. Now in our case, actually, we want to have this be, okay, so we want it to be at 1. So we want to multiply this by another scalar parameter we'll call intensity, which is once again to change the intensity of the color if we need to. Most of this stuff isn't actually going to be changed. I don't think this is even necessary, but just to keep to what I've done before that works, we'll just keep it. Next, we want to do a scene texture once again, and this time we'll do once again the post-process 0. So think of this as just before the post-process is what you get. And we want to add these together. So this is kind of the key part. If you don't do this as an add, or if you do this as a multiply or anything else, then the actual, what we're going to be doing is adding materials on materials, and that's what's going to give us the effect we want. If you don't do this as an add and you do this as a multiply, then you won't actually get the effect that you're looking for. It will just look a bit strange with things skipping in and out of existence and only one area being able to appear at once. So then we're going to clamp, give it between 0 and 1, and that'll be our outline color. So we can call that here outline color. And to finish, this will be a named reroute as well, and it's going to be called outline. Let's make that a different color. It's a bit difficult to tell the difference. So outline, and we're simply going to call that here. So that may look a bit strange here. Let's just start previewing this and stop previewing node. So right now we have this outline, as you can see. Now we're not done, obviously. We still need to apply this, if I remember well. So currently right now, this will be the outline for everything. So let's try and apply that to our actual box and see if that happens. So inside of our post process, we want to look for material. And in post process materials here, we want to add an element. And the element we want to add is actually, sorry, we need to make this an asset reference. And we're going to look for our post process permanent, select it, and we can click the arrow here. And we have an outline on everything. Now, I don't know why it's looking a bit strange. Okay, so I'm back, and so I was having a bit of an issue, as you can see, with my actual outline effect. So the reason for that is, very strangely, it doesn't seem to function correctly if you use the maximum quality selection once you create your project, so which I find extremely strange. So normally I warned you ahead of the video that you need to put the game in scalable. So hopefully that message got through and you didn't run into the same issue as me. So right here, if I go and now I select my material again and I go and get my permanent outline, we can see that it works as intended. Everything is outlined as it should be, and there are no issues. So we actually don't need that. There's the second one. So our post process is just this one. So next up on the list is we need to make our second material. So the post move, or the post add in our case. So we're going to double click and open that. And we'll start off by copying this, because most of it is going to remain almost identical. So you could turn this into a parameter. That would probably make things a lot easier. But in our case, we're just going to go with this for now. So what we need to do is, we have our outline and we don't need to change anything about that, I don't think. I think it's exactly the same. But we need to actually work on some changes here. So first we want to turn it back to a post process. And just like with the other one, we're going to go down to our tone mapping and material here. And make sure we enable alpha. So we need our opacity, especially now. Disable blendable and put priority to 1. We can then apply. And so what we're going to do here is we're going to get a scene texture again, and we're going to get our post process. We're going to call a linear interpolate, or just L, and put it in A for the color. For the B, we want to get our outline, which we made there. And for the alpha, we're going to need to make a sphere mask now, because we only want this ring to appear in a sphere mask, right? So unlike before, we don't need to make it a proper ring. So we'll start with a location with a parameter here, location, which we will then plug into a sphere mask once again on the B. And here we want to get a world position again, apply there, and two scalar parameters, a radius, which we'll put at 150 by default, and another one which will simply use a vector 1 or a float, and we'll put out 0.95. So this goes into our alpha, but this also goes into our opacity this time. The lerp itself will go into the emissive color, because pretty much if we add these together, we need to make sure that we get what's happening behind with this. And if it's not in the mask, then we keep what's behind. If it's on the mask, then we will add our mask on top of it. So that's where the opacity comes in, and the emissive color will deal with what it looks like. So we can apply this, and that's our materials done. Won't need to touch them again. Next, we just need to make our actual blueprint. So for now, this all looks like it's illuminated, but we're going to be changing that once we get to work on the actual material, well, the actor component. So one thing we can actually do is we don't need any of these, because that's going to make it look already more in the ambient that we're looking for. So if you need to work like this, you can always press Alt 3, which will put it in unlit, but we don't have the outline now, so we'll just leave it like this. So currently, if we play, we see everything with the outline, which is, it looks nice, right? But that's not what we want. We want it to actually be completely dark, and when we move or when we apply a sound with our sound generator actor, we then want to actually see everything. So to do that, by default, what we want to do is, sorry, I actually made a mistake here. In the permanent one, we want to, by default, set this to 0. That means the outline will be off. So here, this doesn't look very easy to work with, so we'll put it in Alt 3, so which is unlit. Now, what I did here, so the default one here, pretty much just think of it as if you want something to be displayed. So this is very particular on the case that I had where I wanted a specific color to appear, which we haven't set up. If we want a specific color, then we can use that here. And if it was 0, it would appear here, only with an alpha that we would set with the custom stencil. So now all the work we have to do is inside of our A sound generator. So I'm going to go and open that. Make sure you open full blueprint editor, or it should be by default looking like this as well. It's fine as well. So the first thing we'll do is in our construct script. In our construct script, we're going to set up our actual ring, so to say, our decal. So to do that, we need to get our decal. So let's add it here. This is going to be our actual outline. And I want to make sure that everything's correct. So first, select our ring decal. And we want to make sure the size is uniform. So I put 100 and 100 on all of them, because there is no way to modify the decal at runtime. You can only modify its scale. So we have to do that. So that's why everything needs to be the same here. Just double checking there's nothing else that needs to be changed. Nope, everything left as is other than that. So inside of our construct script, we're going to create a dynamic material. And this dynamic material will be based on our decal. So call that here, ring decal. We want to promote this to a variable, which we're going to call mi for material instance decal. The first thing we want to do here is we're going to set a vector parameter value. And this parameter value is going to be called color. So we're doing this so that we can set it up here. as a variable, which is decal color. And the reason we do that is so that once we spawn this, we can actually tell it to be any color we want. So we're going to make this expose on spawn. So if, for instance, we have an enemy, we just select it as red. Also, by default, we want it to be white. Otherwise, it's going to be a bit weird. So with that, we can now select any color we want the outline to be. Now we'll also make it so that it's not actually going to be able to apply to the decal to the thing here because we can't really tell it to do that. Or at least we could, but it's a bit more complicated, so we're not going to do that for this. Next, we want to call our location from the decal. So call it again, and we're going to say set vector parameter value again, and location. And for the location, well, we're going to get this actor location. So get actor location. And with actor location, just plug it into the color and it will automatically swap it. And the last thing we need to do is we need to get our decal and say set material. And it's going to be set decal material. Apply it like that. And the construct script is finished. Next, we're going to go event graph. And in event graph, we're going to need, first things first, we need to get a reference to the post-process material or post-process volume. So we're going to get actor of class. And obviously get actor of class, we'll select the first one here. And there should only be one, so we don't need to worry about that. So with our post-process, we're just going to record it as a variable here, which we'll call post-process volume, very simply. And for now, we'll leave it like that. We don't need to touch it. Next, what we want to do is we want to get our material, our post-process material, which we're going to be adding after. So once again, create dynamic material instance. And we're looking for post_add. This will also be promoted to a variable, which we'll call post-process material. And finally, now we're going to do the last bit, which is going to be the sound. So pretty much we're calling it sound, but it's the ring, pretty much the size. So we're going to create a variable called sound range here. It's going to be a float. And we're going to plug this in as a times 0.01. This is more about how we write the number on it, because it doesn't really matter. It's whatever you want. But we want to make it visible so that we can change it when we spawn. So expose on spawn as well. And we're going to start by saying, so get our decal here, and we're going to set relative scale. Split that, and we're going to assign it to all three of these because we want it to be uniform. Let's just align that. So the next thing we want to do is, actually there's a few more functions we need, but we don't have them yet, so let's do that. We want a custom event, which we'll call CE_expand. And this is going to be linked to a timeline later, but we just want to be able to call it here. We'll call CE_expand. And then we're going to need another function, which we'll use for the post-process material here. And we're going to say set vector parameter value. And it's going to be location. So this is for our sphere mask inside of the post-process. So once again, like in the construct, we can just grab this, paste, and apply it here. Sorry, like that. And with that, we finished our event graph. We just need to do one last thing, and that is to tell our post-process volume that we've added a material. So to do that, we want to get the settings. And from the settings, we want to break it. So there's a lot of stuff in here, but what we're looking for is the post-process materials. So search them in here and add the pin. We can then right click and split it, which will just turn it into an array. So we can then just add our actual material. So make sure you use add and not add unique. I'm not sure what that would do, but I don't think it's what we want. So we want to then search for make, which will get us a make blendable. So make sure you change the weight to 1. And the object, well, it's the actual post-process material that we made. So let's apply that here. And with that, we've now added a material. Once our sound generator spawns, it will add the material to the actual list that we have, for instance, right here. So if we look at so pretty much it will be adding it to this exact array. So with that, we can now move on to our actual expanding decal. And obviously not just expanding decal, will also be the actual sphere mask as well. So we want to get a timeline, sorry, not up there. We want to call a timeline here, TL underscore decal we'll call it. And we're going to play from start, even though play would work as well because we're only going to call this once. So in my case, we're going to set the variables to 1 second. We want the length to be 1, and we're going to have 3 different things here. So the first one is going to be radius. The second one is going to be intensity. And the third one will be intensity decal. So it's just easier to manage these separately, which is why I'm doing it like that. So we'll start with the radius. For the radius, we want it to go from 0, 0 to 1, 1. So we want to then select everything, and we're going to turn it into an auto because it's just smoother that way. Now let's just make it like that. If you want to modify this, you can. It just has an impact on how it appears. That's the only difference you'll see. So for the intensity, we want to do pretty much the same thing. But once again, the reason we're separating them is if you want to do it separate or different, more like. Because sometimes you want the intensity to be a bit smoother. In my case, I did make some modifications, but to keep things simple here, we'll just do a basic curve. And for the decal intensity, we actually need to do the opposite. We want it to start at 1, and we want it to go down to 0. So we can then also put that in auto so that it smooths out. So now we have our 3 floats here, and we're going to go into our event graph. So the first thing we want to do here is we want to actually create a function we'll call update radius. So update radius here, and it's going to take in a float, obviously, which is going to be radius. Now turn that to a float, and what we want to do here is we're going to use 2 of these, and we're going to update our decal and our post-process material. And we say set scalar parameter value, and in both cases it's radius, but I don't know if we can, well, we can attach like that, so we'll just make things simple. Normally the names are identical, so we shouldn't have any issues here. So compile and save, and we're going to start by calling that one here. So update radius. Now we're not going to directly plug this here. We want this to be our alpha for a lerp. So for the lerp, we're simply going to call our sound range, which is going to be the max range, but we also want to have a starting range, which will be just like sound range. So there, we'll actually inverse them. It makes a bit more sense. Start range will go here. In most cases, we'll leave it at 0. And I'll do it for updating the radius. Next, we want to update the intensity. So for that, we simply want to get our post-process here, our material, and say set scalar parameter value, intensity, and attach the value. Because intensity is 0 to 1, we don't need to have a lerp like this. And then we're going to do the exact same thing, but for the decal, which will get a reference here, drag it there, and into the decal it goes. So now we have our different materials changing as we go, and we just need to do our finish. So as we did with our decal, the actual decal goes visible to invisible. So we can just say at the end here that we want to destroy it. Now the reason we're doing it this way is because we could just destroy the entire actor, but I want it to actually slowly fade out instead of immediately destroying it, right? So we want to have a delay. We'll put something like 0.6, and we'll then call a function called, well, actually we're going to have another function here called custom event CE finish. So what this will do is we'll have another timeline. So let's just call it here. The reason we want to do this is that once the decal expands, we don't want to immediately make our vision disappear. So we want to have it wait a bit and then slowly fade out. So to do that, we'll call another timeline here. So let's get that, TL, and we'll call it fade. So very simply, we'll open it. It's going to be 4 seconds while it's take it very slow. And we'll say intensity again. And we're going to go from 0 at time but 1 in value back down to 0 at time 4. We want to select the two and make them have more of a curve. So with that, we can then move on, and we want to simply call our update intensity again. So we're then going to call one last function, or to be fair, we don't need it to be a function. We just want to get a reference to our settings. So we'll call both of these again, but this time instead of calling add, we're going to say remove item. We want to attach that. Make sure you do select the same, because otherwise you won't be interleaving it properly. And then we can call destroy actor. There we go. So we have pretty much finished our setup here. Oh, okay, I seem to have made a little bit of a mistake here. I'm updating radius. That's a bit stupid on my part. We want to update intensity. That's my bad. I'm completely dumb and didn't even see that. It is getting kind of late. I'm a bit, shouldn't be recording it this time. So let's try doing that again. And it should fade out now. So obviously we can't see the ground very well because there's no actual outline to be seen, but it'll slowly disappear. Now, with that, it is completely functional. Now let's just set it up so that when the player shoots, for instance, he will actually, sorry, let's just move that so the player actually can pick it up, even though he can't see. Let's make it so that when these bullets hit, we actually call the function. Let's do that. So for the projectiles, get it here. And we're going to say create, or like spawn actor from class. The class we want to select is our sound generator. The spawn doesn't really matter. We just want to make sure that we get the actual impact point. So get echolocation will work. We want to have a decal color white. We don't want to bother too much. Sound range we'll put 500. And that'll work. Let's give it a try. So in front of us, oh, well, apparently I didn't, okay, I didn't put it in front of me. I'm a bit dumb. Okay, so let's go forwards. Oh, wait a minute. It's because, okay, it's only when it simulates physics. So let's actually, if it doesn't simulate physics, we'll just avoid it and call this here. Let's do it like that. So let's walk forwards, and shooting the bullets actually spawns our ring. So we can actually move around and see things, and behind us it slowly disappears if we don't do anything. One thing to note is if you shoot, as you can see, if I walk through with the gun and walk out, it's no longer visible because we're no longer in the actual effect of what we shot. So one last thing we can actually do, or I'll show you how to do, is to make it so that it reacts to your voice. Because although it's not necessary, it's kind of an interesting thing to know how to do. So let's get that. It's rather simple. We simply need to add a value called an audio capture. Now, the audio capture works pretty much just like that. We don't have to do anything else. We can just call audio envelope value, and this is going to be when you speak. So one thing to note, I'm going to turn something off here because otherwise you're going to hear an echo, and I'm going to hear an echo, and I don't want to hear that. It's a bit annoying. If you don't want to hear yourself when you talk, you need to disable this. And what we'll do here, for instance, we'll print, just to give you an idea how it works. You need to enable auto activate, otherwise it doesn't work. There we go. So now as you can see, it's actually capturing sound if I stay quiet. It'll be almost silent, obviously, because it's not completely silent. But if you talk louder or makes more noise, then it actually picks that up. So you can use these values to adjust that and make it, well, make sound. So in my case, what we'll do is we'll just make a few variables. We'll say if it's above, so here, if it's superior to 0.04. Now, obviously, this is dependent on your mic. So we'll then make another variable, which we'll call enable voice. Now, this is because we don't want it to be calling every time we make a sound above that, because otherwise it'll be constantly spamming, and that's not very interesting. So we want to kind of give it a cooldown. So we'll then call spawn actor from class, and the spawn actor is going to be our sound generator. Sound generator. We'll get actor transform, and with the actor transform, we're just going to say, let's say 500. Once again, we'll add a small delay of 0.2, and then we'll say, sorry, we actually need to say you are by default true, and on true we want to say you're false. And once the cooldown or the delay is up, we want to re-enable it. So let's try this. So if I talk, as you can see, we have the actual sounds appearing outside. So it's pretty useful when you want to actually find what you're looking for. So now that we have the gun, we can shoot and walk around as well. And it's pretty... Now, obviously, they need some fine-tuning because I think it's linked to my other microphone, and that's why it's not perfectly adapted to what you guys, for instance, hear. So with that, thank you for watching, and I'll see you guys in the next tutorial or next showcase. Goodbye.